Let's continue our discussion on hypothesis testing with testing claims about means. In the previous video, we did testing claims about proportions. Since the methods are really similar, critical value method and p-value method, and the steps are really similar, make sure you watch that video about proportions first, just because I'm going to be going a little faster in this one about means. So let's get started. Let's start with the critical value method. So let's say the US Mint has a specification that pennies have a mean weight of 2.5 grams. A sample of 37 pennies manufactured after 1983 has a mean weight of 2.4947 grams and a standard deviation of 0.01648 grams. Use a 0.05 significance level to test the claim that this sample is from a population with a mean weight equal to 2.5 grams. Do the pennies appear to conform to the specifications of the US Mint? Okay, just like in the last section with proportions, first let's identify the claim. And the claim is that the mean weight of the pennies is equal to 2.5 grams. Notice we're using means here for mu, no more proportions. The opposite of that claim is going to be the mean is not equal to 2.5. So for step 3, when we identify our null hypothesis and alternative hypothesis, the null hypothesis will be the one where it's equals to, mu equals 2.5, and the alternative hypothesis will be where mu is not equal to 2.5. Since it's not equals to, that's going to give us a two-tailed test. Okay, next step. We always are going to need to find the test statistic, and here's where this is the big difference between finding the, assessing the claim for a proportion versus a mean is now we're going to use the T-Test Statistic that we were practicing a couple of sections ago. So the formula we're going to use is T is equal to the sample mean, x bar, minus the population mean, mu, divided by the sample standard deviation over the square root of n. So our sample mean was the 2.4947, and the population mean was 2.5. The sample standard deviation, they told us, was 0.01648, and there were 37 pennies sampled. So this gives us a t-value of negative 1.956. Okay, since we're doing the critical value method, we need to now find the critical value that corresponds to a 0.05 significance level. Since we're using a mean, we're not going to use the standard uniform distribution. We're going to use the student t distribution. So now we need to know degrees of freedom and one-tail or two-tail test. So since there was a sample of 37 pennies, we have 36 degrees of freedom, and we're going to use a two-tailed test. On our student t distribution chart, or using your graphing calculator, and a test statistic of t equals negative 1.956, we get a t-value of negative 1.956. Okay, next, since we're using the critical value, we need to find the critical value that corresponds to a 0.05 significance level, 36 degrees of freedom, and a two-tailed test. Since our test statistic is negative, we compare it to our negative critical value, and the critical value corresponding to a 0.05 significance level in a two-tailed test with 36 degrees of freedom, we get critical value t equals negative 2.028. Now remember, in the critical value method, we're comparing the critical value to the test statistic. So if our test statistic is greater than a positive critical value, so remember the idea is if our test statistic is more extreme. So if it's greater than a positive critical value, or less than a negative critical value, then we reject the null hypothesis. Then we'll be on the outskirts, we'll be in the extreme areas, and we would be in the critical region. We reject the null hypothesis. However, in this value, the critical value is more negative, is smaller, negative 2.02, than our test statistic was. So we fail to reject the null hypothesis. So when we interpret this, remember our test statistic was only negative 1.956. If we fail to reject the null hypothesis, then we're going to keep the null hypothesis and reject the alternative hypothesis. That means that we're going to accept the claim that the mean was equal to 2.5 grams. So there does appear to be enough evidence to support the claim that the mean weight of these coins is 2.5 grams. So it appears they do conform to the specifications of the U.S. Mint. Okay, let's do a p-value method. So, for example, a boat company claims that the mean weight of men is 166.3 pounds. If we take a random sample of 40 men and find that the mean of that sample is 172.55 pounds, with a standard deviation of 26.33 pounds, test the boat company's claim. Okay, now this time we could use the critical value method, but I just want to show you a p-value method example for means. So identifying our claim. The claim is the mean is equal to 166.3. So again, it's a mean, so we'll use mu. The opposite of that claim would be mu is not equal to 166.3. When we're identifying our null and alternative hypothesis, the null hypothesis is the one with the equality, 166.3, and the alternative is the one with the inequality, mu is not equal to 166.3. Again, since it doesn't have an inequality in it, greater than or less than, it's a two-tailed test. Okay, always need to find the test statistic. Since this is dealing with means, we're going to use the T-Test Statistic here. So the sample mean X bar was 172.55 minus the population mean, 166.3, divided by the sample standard deviation, so 26.33, over the square root of 40, the number of men sampled. When we do this, we get a t-value of 1.501. So our test statistic is 1.501. When we're doing the p-value method, we need to find the p-value that corresponds to that test statistic. So using the p-value with the student t-distribution table. A quick note on the student t-distribution table. If you're using the table and you're not using your graphing calculator or a computer, don't worry about finding the exact p-value. We just want to compare the p-value to the significance level. If you want to find the exact p-value, you can use our spreadsheet in this week's project, or you can use your graphing calculator or an online student t-distribution calculator. Since our test statistic is positive, we want the area to the right of our test statistic. And since our test is a two-tailed test, we look up the probability of area in two tails row on the distribution table. And we get that the p-value is between 0.1 and 0.2. Okay, since we know that our p-value is bigger than 0.1, and we know that it is bigger than our significance level of 0.05, remember the p-value has to be more extreme, so smaller than the significance level to reject the null hypothesis. Our p-value in this case is greater than the significance level, so we fail to reject the null hypothesis. Okay, when we go to interpret this, if we fail to reject, that means that we are not going to reject our null hypothesis. We do reject the alternative hypothesis. So there does appear to be enough evidence to support the claim that the mean weight of men is equal to